So in this question, we've been told that Anila is practicing catching tennis balls. She uses a mobile, computer-controlled machine which fires tennis balls vertically upwards from a height of 2.5 meters above the ground. Once it's fired a ball, the machine is programmed to move position rapidly to allow Anila time to get into a suitable position herself to catch the ball. The machine fires balls at 24 meters per second vertically upwards, and Anila catches the ball just before it touches the ground. We've been asked to find to the nearest centimeter the maximum height which the ball reaches above the ground. So this is a projectile question. We'll set up our diagram just as we usually do. So here's the platform, or the top of the machine where we're launching the ball from. Here's the ground and the flight path. I'm showing the initial direction of movement, and I'm labeling that we're 2.5 meters above the ground. Let's collect the rest of the SUVAT variables. For this journey, we're going from the point of projection up to its greatest height. We're interested in the maximum height above the ground. As we collect our SUVAT variables, the initial velocity is 24, the final velocity for this portion of the journey is 0, acceleration, negative 9.8. This is due to gravity, and we do not know the time. We're looking for the displacement. So the formula to use will go with v squared equals u squared plus 2as. Just substituting into this, 0 squared equals 24 squared minus 19.6s. And we can rearrange to find s. Now's the first time we really need to pick up our calculator. Dividing gets us 29.39. Now I've gone for 2 decimal places because the question did ask us to try and give our answer to the nearest centimeter. So I would need 2 decimal places when we're measuring in meters to make sure I'm sticking to the nearest centimeter. Okay, this is the displacement, but this is not the answer to the question. We were asked to find the maximum height above the ground. That means we need to include the 2.5. The displacement is only from the point of projection to its greatest height. It's only a portion of the red line. We need to add in the 2.5. When we do, we get 31.89 meters. That is the height above the ground to the nearest centimeter. In the next part of the question, we're asked to calculate the speed at which the ball is traveling when Anila catches it. So this is when it's just about to hit the ground. We're looking at the entire journey now. Negative 2.5 for the displacement. It's going to end up 2.5 meters below where it was projected from. The initial velocity is 24. Final velocity, we don't know, but this is actually what we're looking for. And acceleration, once again, is due to gravity, so negative 9.8. We're using the same formula, but we're substituting in different values. V squared equals 24 squared minus 19.6 multiplied by negative 2.5. That gets us a v squared of 625. When we square root, the calculator is going to tell us 25, but I know that we're on the way down, so velocity should be negative. Velocity in this case is negative 25 meters per second, just when it's about to hit the ground, and this is when Anila is planning to catch the ball. So a SUVAT question with some nice context to set it up.